Earth is protected by something most people never think about: an invisible magnetic field that stretches tens of thousands of kilometers into space. It deflects charged particles from the sun, shapes the radiation belts, and quietly shields the technology that modern civilization depends on. So what would actually happen if Earth temporarily lost that protection? First, an important correction. Earth's magnetic field does not suddenly switch off. It has never dropped to zero, and it does not flip overnight. When the field weakens or reverses, it happens over thousands of years. But during those periods, it can become much weaker than today. That vulnerability matters. The magnetic field acts as a filter. When it weakens, more high-energy particles from the sun and from deep space reach Earth and near Earth orbit. The first systems to feel this are not people on the ground. It is satellites. Low Earth orbit satellites rely on the magnetic field to reduce radiation exposure. When that protection drops, charged particles penetrate electronics more often. Sensors glitch, memory bits flip, solar panels degrade faster, attitude control systems fail. At the same time, the upper atmosphere heats up because it absorbs more solar energy. That heating causes the atmosphere to expand upward. Satellites suddenly experience more drag. Orbits decay. Some spacecraft that would normally stay aloft for years begin to lose altitude much faster. During strong space weather events today, we already see this effect on a small scale. With a weakened magnetic field, it becomes the norm. Satellite losses would rise significantly. On the ground, radiation exposure would increase, but not to extinction levels. Studies of past geomagnetic excursions show surface radiation could rise by a factor of 2 to 5. That is medically significant, especially for frequent flyers, airline crews, and people at high latitudes. Aviation would be forced to adapt. High-altitude flights would receive higher radiation doses. Radio communication at polar routes would become unreliable more often. GPS accuracy would degrade during solar activity because the ionosphere would become more turbulent. Then there is the power grid. High-voltage transmission lines act like giant antennas during geomagnetic storms. When Earth's magnetic field weakens, electric currents induced by space weather grow stronger. These currents flow into transformers, causing overheating and internal damage. Large power transformers are not simple machines. They are custom-built, heavy, and slow to replace. Some take months or even years to manufacture. A series of failures could lead to prolonged regional blackouts, not because power plants stopped working, but because the grid itself was damaged. This is not theoretical. A much weaker solar storm in 1989 knocked out power across Quebec for hours. A Carrington-level storm under weaker magnetic shielding would be far more disruptive. It is important to understand what would not happen. Earth would not lose its atmosphere overnight. Life would not be wiped out. Oceans would not boil. Mars lost most of its atmosphere because it lacked a magnetic field for billions of years, combined with lower gravity. Earth is not in that situation. Biology would adapt. Technology would struggle. There is historical evidence for this. Around 41,000 years ago, during the last Champ excursion, Earth's magnetic field dropped to about 5 to 10% of its current strength. Radiation increased. There was no mass extinction, but there were no satellites, no power grids, no global aviation, no GPS. The magnetic field is not the reason life exists on Earth. Life survived long before it was strong. The magnetic field is the reason modern civilization works reliably. It quietly protects electronics, stabilizes orbits, and reduces the severity of space weather. When it weakens, the planet remains habitable, but the technological systems we rely on become fragile. That is the real risk. A temporary loss of Earth's magnetic field would not end life. It would stress the infrastructure that keeps billions of people connected, powered, and coordinated. The magnetic field is not a shield for Earth itself. It is a shield for civilization.